Welcome. In this video, we'll be looking at the inverse modulo and the Euclidean algorithm to calculate it. Okay, so let me give you a small introduction. So basically, what is modulo? Modulo function calculates the remainder of a number. Let's say we are given two numbers, 25 and 12. We need to calculate 25 mod 12. So what is the remainder when 25 is divided by 12? That's nothing but 1. So what the modulo function gives, it just gives the remainder when two numbers are supplied to it. So what is inverse modulo? So basically, let's say we have a number a here. Let's say we have an integer a, and we choose an integer x such that if we multiply a and x and then do the modulus m, it will give us the answer 1. This is what is called inverse modulo. So if the definition is not clear, the example will make you clear. Let's say we have a number 4 and modulus is given 11 and we need to calculate the inverse of it. So what we do is we take a number for now, let's say x, we multiply 4 and the number x and take the modulus, it's 1. So we need to find the number x. So by trial and error, I've just chosen x as 3. So if we multiply 4 into 3, we get 12 and 12 mod 11 is nothing but 1. Hence we can say that 3 is the inverse modulo of 4. So this is little easy. This has become just a matter of trial and error. But what do we have? Big numbers. So for that we go for the algorithm which is called Euclidean algorithm. Let's see it. Okay. So let's say we need to solve this particular question of calculating inverse of 204 modulo 151. So yeah, this is the same thing. We take a number x and we multiply with 204 and take a mod of 151. It should give 1. So what is that x? How do we find it? So this is how we find it. First we take 204 and we write it in terms of 151. So we write 204 in terms of 151. It's 1 plus 53 is the remainder. Now what we do, we shift 151 left and we shift 53 left. We express 151 in terms of 53. That's what is done here. 151 is 2 times 53 plus 45. And now we express 53 in terms of 45. So 53 is nothing but 45 into 1 plus 8. And now we express 45 in terms of 8. So 45 is nothing but 8 into 5 plus 5. And this goes on till you get a 1 here. If you don't get a 1 here, it means there is no inverse existing. So if you get a 1, then stop at this particular place. And now what we do? So the previous frame, I have written the content over here. You can see here. So we need to stop when there is 1. Okay. So now what do? Here we express 1 in terms of the other numbers. So starting from here, we write 1 as 3 minus 1 into 2, which is nothing but 2 into 1 taken the other side. So 1 we can write as 3 minus 1 into 2. Now let's say this particular 2, the value of this particular 2, you can get it from here. 2 is nothing but 5 minus 3 into 1. So that is what I've written. 1 is nothing but 3 minus 1 into 5 minus 1 into 3. So if you simplify it, you can see that we are getting 1 as 2 into 3 minus 1 into 5. So this is how the Euclidean algorithm works. We take the value from here, put it here, simplify it till we reach the last. Okay, so for the continuation, the value of 3 is taken from here. The value of 3 is nothing but 8 minus 5. So you can write 2 into 8 minus 1 into 5 minus 1 into 5. Simplify it, you're getting 2 into 8 minus 3 into 5. Again, the value of 5. The value of 5, you're getting 45 minus 8 into 5. Put it here, you'll simplify it, you'll get 1 is 17 into 8 minus 3 into 45. Now again, go to this step. You get the value of 8 is 53 minus 45. So substitute the value of 8, 53 minus 45, simplify it, and you're landing up here. Now go up, you're getting 45 and you're getting in terms of 151. So the value of 45 is nothing but 151 minus 53 into 2. You put it here and you're getting 1 as 17 into 53 minus 20 into 151 plus 40 into 53. Simplify further, you're getting 57 into 53 minus 20 into 151. Now again, go to the last step. You have 53 in terms of 204 and 151. Substitute the value, you'll be getting 1 as 57 into 204 minus 77 into 151. So all these steps are done. Now let's come to the final step. So here's the final step. You have 1 expressed in terms of 57 and 204, 77 and 151. So now what you do, you take 1 mod 151. If you take 1 mod 151, let's see. Here you have 57 into 204 mod 151 and here you have 0. Why 0? because you're multiplying a number into 151 and you have to find the remainder when this particular number is divided by 151, which will be 0 because it will be perfectly divisible. Hence this will be 0 and you are just left with 1 mod 151 is nothing but 57 into 204 mod 151. Now come back to the question. What was the question? The question was to find 204 inverse mod 151. So take the 204 here. So you have 204 inverse mod 151 is nothing but 57. So the answer is 57. You can verify this. You can put 204 into 57 mod 151. You will end up with 1. So inverse of 204 modulo 151 is nothing but 57. Cool? Fine. Now let's take another example. Okay, here you have these are small numbers, but yeah, it's pretty important. You have to find the inverse of 7 modulo 26. So basically you need to find a number mod 26 should give you 1. So let's go with the same steps. Here you have 26 returned in the form of 7 and 5. So here 26 is 7 into 3 plus 5, and again shift left, you have 7 expressed in terms of 5. 7 is nothing but 5 into 1 plus 2, and you have again 5 is 2 into 2 plus 1. 1 is coming, halt. Now express 1 in terms of the other numbers. You have 1, 5 minus 2 into 2. Now this is done. Take the value of 2 from the above equation. 1 is nothing but 5 minus 2 into 7 minus 1 into 5. Simplify further, you will land here. And then here you have value of 5 taken from the first equation. So you can see 1 is nothing but 3 into 26 minus 11 into 7. So this is what the final is done. And then now what? So here you have 1 written in the form of 3, 26, 7 and 11 from the previous frame. So here now we take 1 more 26, this will be left with 0 because 3 into 26 when again divided by 26 would be a perfect divisible, and then the remainder would ultimately be 0. And here we have 7 into 11 mod 26. So 1 mod 26 will be left with minus 7 into 11 mod 26. Now if we take the 7 left side, which is ultimately what the question demands, 7 inverse mod 26 is minus 11 mod 26. Now what is minus 11? We have no such thing called minus number in modulus. Modulus will always range from 0 to m minus 1, where m is the modulus. Let's say we have modulus 26 here, then the modulus numbers will be giving us values from 0 to 25. So what do we do when we get a minus number? When we get a minus number, we add a number which is closest to it to make it positive. So we make minus 11 mod 26 and we had 26 mod 26. Now what is 26 mod 26? Which is nothing but 0. So and then if we just simplify, we get 26 minus 11, which is nothing but 15. So 7 inverse mod 26 is nothing but 15. So basically if you multiply 7 and 15 and then take mod 26, it will give you 1. So this is how the Euclidean algorithm works. Hope you like the video. Thank you.